Hey everyone, so let's look at how we can stop hating the way that we achieve type safety in our fetched data in the JSON that we get back from a fetch call. So let's look at some of the example code that I've put together here. We can ignore briefly these interfaces that I defined. We'll look at those in just a sec. But let's just start here, I think, with this get function that I've defined. So basically I defined a little get function. It's just a simple little wrapper around fetch. And in this case, in our kind of imaginary application here, we're just accepting an endpoint, which is a string. And then internally inside this function, we are calling the fetch API, and we're just passing in our endpoint, and we're concatenating it with /API. So you can imagine if this were a real world app, we might, add this on just to clarify what the endpoint is actually going to. And then if we want to update this in the future, we could do something like API/v2 or whatever. We could use this same kind of abstraction around fetch to do authentication stuff or whatever you might need to do. So yeah, a simple little wrapper function, but it's kind of helpful to have this stuff in applications when you are working with API and fetching data. So then all we really do here is just we return the awaited response.json, and that gives us the JSON response from the API endpoint that we're fetching. So if you look down here, we've got two calls. We have const users equals await get /users, and then we're calling with const limited users. It's the same exact endpoint, but we are using a query parameter to limit that to 10 responses or 10 items in the array. So the main problem right off the bat, if we just have this code in our application, the function has a base level of type safety, I guess, because the endpoint is typed as a string, and you can see that it does return a promise. The promise happens to have a type of any, though, and then when we await that promise, we end up with users, which has an any type, and same with limited users, that has an any type. So not good. We want to make sure that we're getting rid of these any types as often as possible in our applications. And we want to make sure that this users array and this limited users variable, these are both typed as arrays of this user interface. And the properties here are not super important. They're just kind of example stuff. But yeah, in this application, we can think of this as a to-do application. There would be users and tasks. So maybe there's a tasks endpoint that we could call as well. But for now, we're just focused on this users thing. So how would we achieve type safety here? I think the most obvious way to do this is just to use the as keyword in TypeScript to make an assertion. So we could say const users equals await get /users, and we could say as user array. And now, of course, our API response will be typed as an array of user objects. A lot of things that are not ideal about this. For one, you'd have to repeat this assertion every single time you want to call the API endpoint. So down here in our other call, we also have to make the same assertion. And eventually you end up with an application full of these different assertions every single time you need to call any API. And in a more complex application, that's going to get really annoying and difficult to manage. But I think more importantly, what is not good about this is that when we use this as keyword in this way, in a way, we're kind of just turning TypeScript off, and we're telling TypeScript, you know what, like I actually don't want you to really care what we're actually getting back from this get function. I just want you to trust me when I tell you that it's an array of user objects. And TypeScript is just going to say, okay, fine, if that's what you want, I trust you. So if the data structure here changes, like maybe the API changes and we need to update this, maybe it returns an object, and one of the properties of that object is where we actually confined the array of user objects. If any of those kind of changes happen in the API, TypeScript is not going to catch that here. It's just going to blindly trust us when we say as user array, and it's just going to go with that. We'll get type safety down below if we use this user's variable, but TypeScript is not going to question us in here. So that's where we can start to introduce a good amount of risk in our applications when we start to turn off TypeScript in this way and just tell it to trust us. So a step that we could do that's a little bit further than this, a little bit more type safe, is we could, instead of using the as keyword to assert this type, we could pass in a generic parameter to get. So we could say get user array, and we'll have to set up our get function with that generic. So I'll do a little bit of indentation here, and we'll just say response JSON, and we'll just accept it like that. So now we can also actually do promise response JSON as the return type. So now we've typed the get function with a generic type, and it accepts that generic type, and then it will figure out based on that generic type that it's actually returning a promise that resolves to that type. So now we still have const users, and this is properly type checking as a user array, and we can pass in this generic to make that happen. It's one step further than doing an as type, an assertion with the as keyword, but really at the end of the day, it's kind of the same approach. You're sort of just telling TypeScript, I'm going to tell you what the return type is supposed to be, and I just kind of want you to trust me on that and not question that. And of course, same problem as the as keyword, you have to repeat this generic and manually pass this every time you call this particular endpoint. And if the response type of this endpoint changes, you're going to have to go through your application and update all those different generics that you passed in. So not super ideal. I think we can do one thing actually that would add a little bit of an extra layer of type safety. We could add a constraint on this generic. So we could say response JSON extends, and we could say this is going to be either a user array or a task array. This is a little bit better because at least TypeScript is it's not 100% blindly trusting anything that we pass into the generic. It is at least making the assertion that this has to be a user array or a task array, and it's going to assert like, okay, those are the only two things that you can potentially fetch from an API using this get function. So if I change this to string, we'll get a type error, which is nice because it means that I have to at least be a little bit stricter with the types that I'm passing into this generic. So slightly better, but still haven't really solved that problem where TypeScript is just kind of turning off and trusting us and trusting the data that we pass into here. Plus, if you look at this code, it is, I think anytime you introduce these angle brackets and generics, very quickly you start to get into a place where the code doesn't immediately make sense to somebody who's less familiar with TypeScript. I think it wouldn't take that much reading of the documentation or TypeScript study to figure out what a generic is and what it does. But for somebody who's just learning TypeScript, or somebody in your organization or on your team who is not necessarily, being a TypeScript expert or even being that familiar with TypeScript, maybe is not a huge part of their role. I don't love introducing the generic syntax and forcing people to manually pass that in every single time just because we can't think of another way to make this type safe. So let's push a little bit further, and let's actually just delete this type and take a step back and think about what we know as human beings when we read this code, right? So when we read const users equals await get / users, as a human being reading that code in this application, if I were working on it, I would instantly know, okay, this is the users, this is returning an array of user objects. And the way that I would know that is by reading the / users endpoint. This parameter, this function parameter, this is what's giving me the information about the return type. So it would be really nice if TypeScript could also read that endpoint and kind of infer the same information. And if you watched my previous video, you might recognize some of the stuff we're about to do. So there's definitely a way to do this. We can have TypeScript read the endpoint and then basically look up the corresponding response JSON type based on that endpoint. And so the way that we'll do that is we'll remove the response JSON generic type and we'll replace it with a generic type that we'll call endpoint, and we'll say that extends string. And then our endpoint parameter in the function, instead of just setting that to string, we'll set that to the endpoint, capital E endpoint generic type. And so now get is basically, instead of making us pass in a generic manually, get is going to infer the endpoint generic type. It's going to infer the value of this type from the type of the parameter that we pass in as the actual endpoint. And I think this should already be kind of working. Yeah, so we have to fix our return type, obviously, but if we hover over this await get / users, you can see that function get, the generic type is getting filled in as / users because TypeScript is reading / users from our endpoint parameter, and it's saying, okay, so whatever this generic type must be, it has to be / users. So that's cool. That's a step in the right direction, right? Because again, we as human beings know the return type of this function because we read the endpoint. TypeScript now at least is able to read the endpoint. It's still not it's still not quite aware of what the return type is based on that endpoint, but we've kind of got the first task done, which is make sure TypeScript is actually able to read this endpoint in the same way that we as human beings would read it. And so now, to actually wire this up and make it type safe and make it realize that whatever endpoint is being passed in, it has to go look up the corresponding return type for the response JSON. We can set this up. We can set up an interface, actually. We'll come down here and define an interface, and we'll call this interface response JSON by endpoint. The idea behind that name is we are going to actually, let's just let Copilot autocomplete some of this stuff. So this is an interface that we're defining that's going to allow TypeScript to look up the return type of an API endpoint based on the string value of that endpoint. So I'm calling it response JSON by endpoint because I'm trying to look up the response JSON type based on the endpoint, by the endpoint. So that's just kind of a convention that I like to follow when I'm creating these interfaces. But let's wire this up in the get function so we can see how it actually works. So we'll say the promise is going to be, it's a promise that resolves to response JSON by endpoint, square brackets, and then we'll put our generic endpoint type in here. And you can see we'll get a type error, and it's telling us type endpoint cannot be used to index type response JSON by endpoint. So this type error basically is saying endpoint, according to our generic, can be any string. It doesn't have to be /users or /tasks. It can potentially be any string according to TypeScript. And so since it's any string, we can't look that up. It's not okay to look that up on this interface. If you were in JavaScript, you would look, you could, the analogy here is looking up a key on an object when that key doesn't exist. And if you do that in JavaScript, you'll get undefined. But in TypeScript, there's no concept of doing it that way. So instead of giving you undefined or something like that, TypeScript will just throw a type error and say, you know what, if you don't have a string that actually is one of the keys of this interface, I'm not going to allow you to look up a type value based on that string. So the way that we fix this is instead of having endpoint extending string generically, we're just going to say endpoint extends key of response JSON by endpoint. And you can see we've got a little type error down here. We'll check that out in just a sec. But let's talk a little bit more. Let's talk through again what this is actually doing. So in our get function, it accepts this generic type endpoint. And when we pass in an endpoint as the endpoint parameter, it's going to infer the generic based on that. So if we hover over get, await get, we can see /use. We're passing in the endpoint as users, and TypeScript is inferring, okay, the endpoint, capital E endpoint, the generic type, that has a value of /users. And then it's doing a quick check to say, okay, actually I want to just make sure that whatever you're passing in is one of the keys of response JSON by endpoint. So if I pass in something else here, that's not /users or /tasks, that's not one of the endpoints listed in our interface, then TypeScript is going to throw an error, which is good because this would be an endpoint, a new endpoint that doesn't have type safety configured yet. So if we want to maintain this over time for an application, it would be pretty straightforward. If we have a new endpoint, we just come in here and register that new endpoint. Basically, we just add a new key to our response JSON by endpoint interface, and we toss in the corresponding data type that, in theory, would be returned from the API call to that endpoint. But for now, let's just keep those two. So once TypeScript figures out the value of that generic type and then does a double check to make sure that it is one of the keys of response JSON by endpoint, it is then in the return value, it's going to return a promise, and that promise is going to resolve to response JSON by endpoint, square bracket endpoint. This is, in TypeScript, we call this an indexed access type. That's the technical term, but really all this is doing, it's very similar to looking up a value of an object, and we'll just kind of demonstrate that here. So I'll say type example equals response JSON by endpoint, and we'll do /users. All this is doing is saying, okay, TypeScript, I want to create this new type, and you can see it's already being set to the user array. So it's saying, go to this interface and look up the value for this key that I'm going to give you. So in our function, it's looking up the endpoint, whatever the generic endpoint happens to be. It's going to go to the interface and look up that value, and that is what's going to become our return value. So this is really cool because we'll ignore this type error. We're going to touch on that in just a sec, but at least look at this first line of code here that we would have. You could imagine this being in userland code in our application in some page or some component or whatever. So const users equals await get slash users. This is just plain JavaScript right here. If you were totally new, brand new to TypeScript, coming into this application and working on this code, you'd be able to read this and you wouldn't have to give it a second thought. You'd know as a human being, const users, this is going to be an array of users. And also, TypeScript is going to know that based on the generics that we've wired up here and the key of operator and all this stuff that we've done. TypeScript is also able to read the endpoint in the same way that a human being would, and it's able to figure out, based on the interface that we're maintaining separately, probably in some other file in our application, tucked away, and that complexity is all going to be hidden from where we're actually interacting with this code and using it in the app. And TypeScript is able to do that and read, okay, so users is going to be an array of user objects. And this is really fantastic because it makes the application code easier to write and maintain and easier to read for people who are not as familiar with stuff like generics. They don't actually have to know that any of that is wired up or how any of that works behind the scenes, because all they're really doing is just writing plain JavaScript and getting type safe data responses back. So now let's talk about the other type error here, right, with the URL parameters example. So if I hover over this, the type error is argument of type /users limit equals 10 is not assignable to parameter of type key of response JSON by endpoint. So what this is saying is TypeScript is basically, it's doing that little double check with our generic constraint is what this is called. When we have a generic type and we say extends and put some other type in here, that technique is called a generic constraint. So TypeScript is saying, okay, this /users, whatever, with the URL parameter, this is not one of the keys of the response JSON by endpoint interface. The only keys on that interface are /users and /tasks. And /users limit equals 10 is not one of those keys. So it's going to throw a type error and it's going to tell us this is not valid. One way we could solve this problem is by splitting the string. So we could say, instead of doing get and then pass in the entire API endpoint with URL parameters all as one string, we could just kind of split it in our userland code. And so we could pass in the endpoint as the first parameter, and then the second parameter, we'll just call that URL params here, and we'll just set that to a string. And then, of course, in the body of the function, we would just concatenate that on. And actually, we'll make that optional as well. And we'll do, if that's undefined, we'll just resolve it to an empty string. So internally, the function should totally be working. That's all going to be fine. And in our userland code, we can hover over const limited users. This is properly being detected as an array of user objects. And then where we see await get, this is inferring the /users endpoint, and it is, returning the promise that resolves to a user array. So this is cool. What I don't like about this is that, again, thinking about this from the perspective of somebody coming in here without knowing a lot of TypeScript or without knowing any of this kind of TypeScript complexity that's going on behind the scenes with the get function, they would see this and they would think, why is this happening? And then they might read the body of the function and they're thinking, like, if you're literally just going to concatenate these two strings together, why do we have to go through this extra work of splitting them into two things? If you were writing this application in plain JavaScript, you would not do this. This wouldn't be something that you would need or want to do because it's just introducing unnecessary cognitive load and complexity into the function that doesn't need to be there. So that's probably the main reason why I don't like this approach. It's not it's not a lot of work to manually split these strings and just pass them as two strings instead of one. But yeah, it's not the work that I'm worried about. It's the unintuitiveness, I guess I would say, of having to do this, because really the only reason we're doing this is to kind of babysit TypeScript into being able to figure out and read our our endpoint value and making sure that that is all working. And that's kind of a theme of how I like to work with TypeScript. Anytime I feel like I'm babysitting TypeScript to make it catch up with me, to read information that as a human being I'm already able to read very easily and see things that are obvious. Like anyone could see this and say, okay, get /users limit equals 10. Any human being who's working on this application, it's going to be incredibly obvious to them that this is going to return an array of user objects. So we don't want to go out of our way to babysit TypeScript just so that it can read things that are already really obvious to us as human beings. So instead, what we can do, we'll keep this all as one string. We'll send it back to where it was when we were writing as if we were writing plain JavaScript. And then in the function, let's get rid of this URL param stuff and forget about that. The way that we can support this is by creating a union type for this endpoint parameter. So instead of endpoint being just endpoint, we can use what is called a template literal type. So we can say backtick $ curly brace endpoint, put our generic type in there, and then question mark, and then another $ curly brace, and put in string here. So what this is saying is the get function is saying, okay, pass me the endpoint. This endpoint can either be one of the keys of the response JSON by endpoint interface, or it can be one of those keys with a question mark after it followed by any other string. And in URL, anytime you have a question mark, that's going to be the only question mark in the URL, and that's going to come right before the URL parameters. So we can safely set up that type and assume that this will work for any endpoint and combination of URL parameters that we might pass in. So now if we look down at our userland code here, const users equals await get /users. If we hover, actually we'll do the limited users one. So limited users, you can see this is properly being detected as an array of user objects, and then await get. If we hover over get, we can see get is reading the /users endpoint, and the type is interesting here to read. So for this endpoint parameter, it's saying this can either be /users or it can be /users question mark with followed by any string. And our string happens to match that pattern because it's /users question mark limit equals 10. This would be the part that's matching this string type that we're passing into the template literal. So very cool feature, not super commonly needed, but it can get you out of some really tight spots like this one and add a little bit more flexibility into how TypeScript is able to read the information that you're passing in. Always, right? Always with the end goal of being able to write the simplest possible, most intuitive code in your actual application code, making sure that it's quick and easy to write and maintain, making sure that you're not using brittle assertions with the as keyword or just passing generics in, and of course making sure that this code in an ideal world should make sense to anyone who's coming into this application and working on it with limited knowledge of how TypeScript works. And even for people who do know how TypeScript works, right? Even those people are going to benefit from being able to write basically plain JavaScript code and then not having to worry about all this complex TypeScript going on in the background. This is all going to be in a separate file, managed separately. We're not going to have to see it or think about it. We're just going to call API endpoints in our app code, and we're going to get back type-safe responses. So really cool, really similar to what we were talking about in the previous video I did about inferring event types from the name of events that we want to listen to. But I think there's some bigger lessons to be learned here, some interesting stuff to think about. So let's think about the flow that we went through when we were writing the code in this video. So first we started off with some code that was not type safe and it used the any type. And we said, okay, the problem in this case is the any type. Let's get rid of the any type. We did that using the as keyword. Then for various reasons, we decided, okay, actually the as keyword is going to be problematic for us. That's the problem. Let's solve that problem. Let's get rid of it. And we did that by introducing a generic type with a generic constraint as well. And then we said, okay, the problem is that this generic constraint thing is working, but for various reasons, it's still brittle. It's not going to be a good solution for us long term. It doesn't look great, and let's get rid of it. So we redefined the problem again and said, okay, we want to rewrite this code to still make it type safe, still not have an any type, not use the as keyword, and not use a generic that's passed in manually. And then we made the jump to, I think there's a decent cliff there where all of a sudden, instead of just using generics or the as keyword, we're combining generics with type inference and the way that works in TypeScript, the key of operator, this concept of index access types. All of a sudden, a bunch more features were thrown into the mix and composed together to make this work. But still, at the end of the day, it's about the problem space being redefined as we want this code to not force us to pass a generic in manually to get it working. And then in the final step, to support this URL parameter thing and make sure that we didn't have to split our string for some strange reason into two different strings that are just going to get concatenated together anyway, we introduced the template literal type, which is kind of the final TypeScript feature that we brought into this problem space to help solve our problems. But the problem in that case, the problem that we were trying to solve was that the code is working, it's type safe, it is inferring, it's all automatic, but it doesn't look exactly like the code that it doesn't look or work exactly like the code that we would write if we were just writing in plain JavaScript. And what I think is really interesting about that progression is that you can apply it to so many different problems in TypeScript, and very quickly you can start pushing yourself to learn these different features, figure out how to compose them together. And really, I think if you did it for 6 to 12 months maybe in your application, you'd probably be as good as the top third TypeScript developers in the world. I don't think there's that many people that can readily combine key of, index access types, generics, inference, all this different stuff to solve these problems in really clean, really smooth, really automatic ways. It's not a big group of people that are able to do that. And it's because the problems are hard, right? There's a lot of features involved here. There's a lot of stuff that you'd have to go to the TypeScript docs to learn. And you can't really, it's hard to learn all of these features in isolation. If I just taught you something about template literals, it wouldn't really make sense, because where are you actually going to apply that feature and how is that useful in any way to your day-to-day TypeScript needs? So there's definitely a cliff at a certain point where you kind of fall off and the problems get more difficult and you have to combine more TypeScript features together to solve them. But I do think that, I think that you can pretty reliably become basically a world-class TypeScript developer. You can enter that top third, if not the top 20% of TypeScript developers, by following that same pattern of defining problem spaces. So the first problem would be get rid of all, anytime you see the any type in your application, get rid of that. Then moving on from there, if you see the as keyword, get rid of that. Then after that, you'll probably have a bunch of generic types manually passed in, scattered around, and you can start to get rid of those. And then once you get rid of those generic types, it would be like the final boss of TypeScript, which is whatever you're doing in your code here, make it look and work exactly like you would want the plain JavaScript to work, and just use TypeScript features and write little type systems to make sure that stuff all stays type safe and you don't end up with any types or any brittle assertions or anything like that. So that's kind of the meta lesson that I wanted to talk about in this video, and thinking about the previous video I did about this stuff as well. I think it's a really cool process that you can follow pretty reliably in a lot of different problems in your application. A lot of different functions could benefit from this kind of approach. And if you do that long enough, you're very quickly going to get a skill set that not a lot of people have. And it's going to push you to learn TypeScript features that never would have made sense otherwise. If you learned them in isolation or just read the docs front to back 20 times, the features still wouldn't make sense, because you have to confront these real world problems and combine TypeScript features to solve them. And that's when everything starts to click. So very long rant there, but hopefully that changes the way that you think about TypeScript and the way that you approach your own code bases. I love talking about this stuff. If anybody has any questions about these features or how I've combined them to solve other problems that I have in my apps, happy to field any of those questions or just talk about it. So I will see you in the next video. And this TypeScript stuff is cool. I think we're going to keep diving into it. I will get back to talking about Vue and probably some React stuff very soon. But yeah, I hope you enjoyed this one. We'll see ya. Bye.